Hey guys, in this video I'm going to go through a quadratic application question where we have a rectangular garden and we need to work out the maximum area. It's a question testing your understanding on finding the maximum value of a quadratic function, and in the second part it's testing your understanding on ratios. So continue to watch this video as I show you how to approach this question. And so reading the question, we've got Georgie has a large rectangular garden area with dimensions L meters by W meters, which she wishes to divide into 3 sections so she can grow different vegetables. She plans to put a watering system along the perimeter of each section. This will require a total of 120 meters of hosing. Part A. Show the total area of the 3 sections A meters squared is given by A is equal to 60W minus 2W squared, and hence calculate the dimensions when the total area is a maximum. To begin with these types of questions, what we need to do is write the general rule for the area that we're trying to maximize. For this question, we want to find the maximum area of a rectangular garden. And so in general, to find the area of a rectangular garden, this is found by its length times its width. From here, what we need to do is get the right-hand side to be in terms of one variable. And this is going to be the variable W, since the rule that we're given is in terms of W. And so if we let the width of this rectangular garden to be W, we need to work out the length of this garden in terms of W. And now the question is, how do we do this? Well, we need to use the information that's given to us. We've been given a condition, in other words, a constraint, and that is that we've got 120 meters of hosing that we can use for the perimeter of the 3 sections. And so this is a clue that we need to somehow use the perimeter of the 3 sections. The perimeter of the 3 sections can be calculated as 2 times the length of the garden plus 4 times the width of the garden. And so we can write another equation stating that the perimeter is going to equal 2 times the length plus 4 times the width. And given that the perimeter has to be 120 meters, then we can say that 2L plus 4W is equal to 120. Now we have an equation in terms of L and W, and rearranging this we can solve for L and have it in terms of W. And so rearranging this, we're going to get 2L is equal to 120 minus 4W, and dividing both sides by 2, we're going to get L is equal to 60 minus 2W. And so L, the length of this garden, is going to be 60 minus 2W. Now that we have the length in terms of W, all we do is sub it into the general rule for the area. And so the area is going to be 60 minus 2W times the width, which is W. And so expanding this is going to be 60W minus 2W squared, as required. The second part of this question is asking us to work out the dimensions when the area is a maximum. Given that the rule of the area is a negative parabola, to find the maximum area we need to work out where the maximum turning point is. And here's where you can approach this question in different ways. One way is to use the method of completing the square and rewriting the rule for the area in turning point form. You would use this method because if we can rewrite the rule of the area in turning point form, we can immediately read the coordinates of the turning point, which will tell us for what length W we're going to get the maximum area and also what the maximum area would be. But since we're not asked to state the maximum area, I'm going to use another method, which is going to be quicker than completing the square to answer this question. Now the general rule for a quadratic equation we know is y is equal to ax squared plus bx plus c. And we know that for quadratics or parabola graphs, the turning point lies in the axis of symmetry, where the x-coordinate is equal to minus b on 2a. And so for this question, to find the length of W where the maximum area will occur, we need to let W equal minus b on 2a, where b is the coefficient of the W term and a is the coefficient of the W squared term. And so subbing in these values, we're going to get minus 60 over 2 times minus 2. The 2 negatives will cancel, and then we'll have 60 divided by 4, which is equal to 15. And so when the width is 15 meters, we're going to get the maximum area. And so finally, answering this question, the dimensions of the garden for the maximum area is going to happen when the width is equal to 15 meters. And the length, we know that this is 60 minus 2 times the width. If the width is 15 meters, then this is going to be 60 minus 30. And so the length is going to be 30 meters. Part B. Using the maximal total area, Georgie decides she wants the areas of the 3 sections to be in the ratio 1 to 3. What is the length of hosing for the watering system that is required for each section? We just worked out that the maximum area of the garden will happen when the width of the garden is 15 meters and the length is 30 meters. And so what we need to do now is break up this garden into 3 sections with a ratio of 1, 2, and 3. Knowing now that the width is going to be 15 meters and the length 30 meters. And the trick to this question was not to break up the maximum area into 3 sections, but the length of the garden, the length of 30 meters, into the ratio of 1, 2, and 3. This will be section 1, this will be section 2, and this is going to be section 3. To work out the length of hosing needed for each of these sections, we need to work out the length of each of these sections. We note that the width is going to be 15 meters. To work out the length, we need to use the given ratio, 1, 2, and 3. And the way we do that is we first add these numbers. And so adding 1 plus 2 plus 3, we're going to get 6. What this means is that for each 1 meter of hosing, we're going to split it into 6 parts. And so the first section is going to have a length of 1/6. The second section is going to have a length of 2/6. And the third section is going to have a length of 3/6 of 1 meter. But we have 30 meters. And so what we need to do is multiply these fractions by the total number of 30. And so the length of the first section is going to be 1/6 times 30. Which is equal to 5. The length of the second section is going to be 2/6 times 30. This is going to be 10. And the length of the third section is going to be 3/6 times 30, and this is going to be 15. And so this length is going to be 5 meters, this length is going to be 10 meters, and this length is going to be 15 meters, giving us a total of 30 meters. Now that we have these lengths, we can work out how much hosing is needed for each section. But you need to be careful here. For the first section, the total meter of hosing needed is going to be 2 times the length plus 2 times the width. And so for the first section, this is going to be 2 times 5 meters plus 2 times 15 meters. This is going to be 10 plus 30, which is equal to a total of 40 meters. For the second section, you only need hosing for 3 sides because one side is already shared with section 1. And so the total number of hosing needed for this section is going to be 2 times the length, which is 10 meters, and then plus 15 meters, which is the width. And so this is going to be 20 plus 15, which is equal to 35 meters. And for the third section, again, you only need hosing for 3 sides. And so the total number of hosing needed for the third section is going to be 2 times 15 meters, which is going to be the length, and then plus 15, which is going to be the width. And so this is going to be 30 plus 15, which is equal to 45 meters, giving us a total of 120 meters. And that's it for this question. Now the second part was tricky, but hopefully this all made sense. And if it did, and if you found it helpful, then like this video or comment below and let me know. Good luck, and I'll see you guys in the next video.